before the explanation of the Bayesian approach, we need to do a technical adjustment that is very useful. So we are going to create new variables. So remember that in the ANOVA approach, we created dummy variables. So this is in a sense similar to that. We are going to create mean-centered independent variables. So instead of using the variable in the raw values, we are going to create a mean-centered new variable. How do we do that? It's very easy. So for the two independent variables, group practice and individual practice, we subtract the mean from each of the raw values. So in terms of group practice, the mean was 7,921. So if your raw value in this variable was 0, then now you subtract the mean. Now your value will be negative 7,921. How do you interpret that? Well, that is how far you are from the mean. And the negative sign means that your value is lower than the mean. If you have a positive sign, it means that your value is higher than the mean. Now, if your practice, your raw score is the mean, 7,921, if you subtract the same value, you obtain 0. So now what happens is that the mean of these mean-centered variables is 0. Okay, so we subtract the mean from all the values. So now we've got negative values, positive values, and the mean of that new variable is going to be 0. Okay, so what's the consequence of doing this? Well, some very interesting consequence is that, remember we mentioned that the beta 0, it doesn't have an interesting meaning. So here, what we are going to do is to almost getting rid of beta 0. Look at the null model, and again, just take into account that the graphs present models that take into account one variable at a time, not a model in which the two variables. It's just more difficult to represent, so I'm not going to do that. Now, the null model is the mean model. That means that beta 0 is the mean of national rating, which is 1,988, and the beta 1 is 0, and the beta 2 is 0 as well. So that's the null model. Now look at the estimation of the parameters in the mean-centered model with the two variables. If you see, the beta 1 is exactly the same as in the case of the raw variables, 0.0127. And if you see beta 2 is exactly the same, 0.0062. But what it changed is the intercept. The intercept now is 1,988. And look at that. That's exactly the same as the null model. Why is that? Well, I show you in the graph. So here on top are the raw values, and on bottom the corresponding mean-centered variable. So when you've got the mean-centered variable, now the mean is 0. So this vertical line shows the mean of total group, which is 0. And same with individual. This is the mean of individual practice. Now, and in red shows the mean of national rating. If you see the regression line of the linear model, it intersects where the two means intersect, right? Okay, now remember what was the meaning of beta 0, which is, or the intercept. The intercept is the value of the y variable, which is national rating in this case, when the value of the independent variable, in this case group practice, is 0. But now 0 is not the left in the left extreme. 0 is in the middle, or not in the middle, but it's the mean of this variable. And here then beta 0 will be this value, which is the mean of national rating. So by doing this, it means that beta 0 is the same as the mean of national rating, and it's not going to change. We can create more complex models, and that value of beta 0 will always be the same. And so now the beta 0 is almost what it has to be, which is not very interesting and not a very interesting parameter. So it tells us only what's the mean of national rating. But beta 1 and beta 2 have the same meaning as before, and by changing this, it didn't change the value that is the best estimate.